Hello guys, welcome to my channel again, and this time again as usual I'm going to solve a contest, and this one will be bi-weekly contest 161. And just before starting, I just want to say that like the live stream, like there is a problem with my laptop. I don't know what it is, but like prolonged live streaming sometimes, like I don't know what happens to the laptop. The live stream automatically gets like I come out of the live stream somehow, like it automatically gets shut down for some reason. I don't understand why, but yeah, for that I'm apologizing before. If that happens, I am extremely sorry. Yeah, I'll probably have to make the video private, or if you want not to make it, I can still go with that. But yeah, I'm just I don't know what's wrong with my laptop. This is this problem has been over a long time now. Anyways, so yeah, so this is the contest I'm going to solve. So yeah, let's see how many questions I can solve. Every contest makes you better at problem solving, because you know learn new concepts, new things. Okay, so the first question is, you are given an integer array nums. I have to split array by prime indices. So split nums into two arrays A and B using the following rules. Elements at prime indices must go to array, other elements must go to V. So return the absolute difference between the sums of the two arrays. Okay, like this is way easy here than I thought. Wait, nums of I can be negative as well. So how are we? Okay, prime indices. Yeah, so index, if you look at the indexes, you can see that okay, I think I can just do the sieve algorithm here. So let me do this. So what I'm going to do is have a vector which will tell me composites, right? And this will be 0, or maybe I can, like, I should not do it a lot of times. I can just call a sieve, this function sieve, right? The n root n can also work, but yeah, let's just write the sieve algorithm. So there's this composite of 0, which will be composite of 1, because they are composite numbers. And for int I equals to 2, I is less than n, sorry, I times I is less than n, I plus plus. If it's not composite, if I is not composite, then I am going to go to the square of I, and then except for the I, all other multiple of I starting from I square. And because if it was not less than I, it is already something which I have made composite, so I don't need to worry about that. And this is just typical sieve algorithm. So yeah, and also I also need this thing, const int n, which is 1e5 plus 1, or actually 1e5 works. What does prime indices go like? For example, the only prime index in the array is 2, yeah, okay, which is 4, yeah. So 1a5 is alright, and I'm going to have this bit set composite, right? And yeah, I'm done. Here I just need to make the constructor so that I allow this function to yeah, so I want to run this function only once and not more than once, so that's why I am doing this. Yeah, that's nice. And if you look at this 10 to the power 5, the maximum number that it can go to is 10 to the power 9 into 10 to the power 5. So yeah, so now I am just going to do this long a, and which is 0, and b is also 0. Okay, now for I equals to 0, I is less than I plus plus, if composite of I, then b plus equals to nums of I, right? Else if it is not a composite number, then I am going to put the nums I into a, and then I am just going to return this value over here. Yeah. Oh shit, true and return. Why is it 1? This should be 3 then. Yep, let's submit this. What's wrong with this one? Do I need to do LL? Something like this, or what? I don't know. Sorry. LL ABS. What's wrong, guys? How can this be wrong? What do I really need to find out? Like this is absolutely different between the sum of two arrays. Elements are prime indices in nums. I will go to other elements. So yeah, I literally did that, isn't it? Oh, okay, this is the reason. C function I wrote. C function wrong. Man, I already got a penalty. Anyways, so the next question, count islands with total value divisible by k. I don't know what it means. So you are given an m cross n matrix grid, which is this one, into and a positive integer k, which is this one. An island is a group of positive integer representing that they are 4 directionally connected. Okay, the total value of an island is the sum of the values of all the cells in the island. Alright, it is the number of islands with a total value divisible by k. Okay, I like, do you think simple DFS can solve this problem, right? It looks like simple DFS will be able to solve this problem. Once I reach a 0, I just don't do anything, and whenever I stop the DFS, yeah, I think this is quite a, like, just DFS is going to solve the problem. And M and N are 1000, so yeah, DFS will work. So let's try to make the function DFS. And at worst case, what is actually going to happen? Yeah, it's just a simple DFS will do. I need to find out the total number of islands with the total value divisible by k. Yeah, it's easy. So let me do this DFS and TU. Okay, and we have this vector of grid. Okay, so it's not a single node. I can make a single node by combining like indexes. I can do like this 0, 1, 2, 3, 4 and then start this index with 5, but yeah, it will be headache. I don't want to take so much headache. As you can see, it's 4 directionally connected, so I need to use dx and dy's such that it's only that only allows me to visit everything 4 directionally. And I am also going to have the visited array, which I will make it global. Yeah, this is great. And also another thing, I'll make it global, which is this guy. I can only travel horizontally, so for that I'm doing this. Yeah, and now I am having this. So yeah, so at first viz of I of j will be 1, and how am I even using viz of I? So I need this thing, grid dot size m grid of 0 dot size. Okay, and another thing also I'm going to try to do, which is assign n m with 0. This is actually I don't actually need to write a 0 here, but it's fine, it works. After I do that, yeah, so simply do the normal TFS. Okay, so the thing is, I'm only going to visit is if, so let me also write the newer cell ni, which will be I plus dx of k, and nj, which will be j plus dy of k, right? And I'm only going to visit if it is not out of bounds. So this is an out of bounds checker, and I have not used here, so I am just going to have to do this, and nj, which ni is greater than equals to 0. Similarly, I have nj, which should be grid 0 dot size, and nj is greater than equals to 0 as well. So this will make sure that they are not out of bound. And now what I'll do, if not visited, if they are not visited, and at the same time okay, at the same time it's the there is some value in the grid. So grid values can never be less than 0. So yeah, if the grid has some value, it should not be 0, right? If it's 0, then it's not an island. Sorry, this I'm talking about the newer NIs. Yeah. If these two are true, I have not visited them, and grid I, then I am going to do this TFS of ni, nj in grid. Yeah, and also I am going to have this value, which is here, and the value is actually the sum of values in the cell. So sum. So as you can see, sum is almost 10 to the power 6, and if everything is, let's say, 10 to the power so let's try to say that there are a total of 10 to the power 5 things, so it will be 10 to the power 11 at max, and I don't think 11 fits in, so I need a long here, right? Or maybe like just a boolean function here, right? Correct? A bool can work, but it is not going to give you the sum. I need the sum of the DFS. Okay, Yeah, I think I need a sum instead. So long ways, okay, it's going to give me long values, yeah. And what really I'll do here is, sum is equals to, when I come here, I'm like, okay, this guy, like I'm going to do this at first, grid of ij, and then I'm just going to add these values, sum plus equals to, okay. When I add these values, after that I just return sum. That's what I really do. Yeah. So this is quite alright. I think the DFS is. I just need to do this for ti equals to 0, I is less than n, I plus plus. For int j equals to 0, j is less than m, j plus plus. If I see that I and j is not visited, then I am going to have to, if DFS of I comma j comma grid is divisible by k, then I'll have something like counter, let's say, which is 0, and I'm going to increase the counter, right? This is what I'll do. So, and then this thing is going to happen. And not only this, actually, I also need to do this grid and of I and j, correct? Only travel when grid is something. If they are already 0 and grid is already, why do waste time and try to do a DFS there, right? And then return the counter. 2, which is correct, and then 6. Yes. So normal simple DFS question this was. Okay. So the next question. Network recovery pathways. You are given a directed acyclic graph. So there is no cycle and it's a directed graph, which is really cool because there are no strongly connected components, and it's almost like a tree, I guess, but it's not actually a tree. Anyways, I'm just talking just stupid. Okay, end nodes. This is represented by 2D array edges. So these are the edges of length m, yeah, where edges are this indicates a one-way communication from UI to node vi with a recovery cost of const I. Okay, yeah, so there is only one-way communication from, you can, if there is an edge between u to vi, you can talk from ui to vi, but you cannot talk from vi to ui unless there is a edge connect which connects vi to ui. And so the cost of doing, I think recovery cost, I don't know what it means, but I'm assuming that in order to communicate u to with v, u to v, I need this much cost. Some nodes may be offline. You are given a boolean array online. So I am giving this array. So some nodes may be offline. Okay. It just means that if it's true, if a particular index is true, then that node is actually online, and if it's false, it's just no. Okay, node 0 and node n minus 1 are always online. So yeah, this is also given. So a path from 0 to n minus 1 is valid if all intermediate nodes on the path are online and the total recovery cost of the edges on the path does not exceed k. Okay. So it's like I'm thinking of something like Dijkstra. What do I need to find? For each valid path, define its score. Dijkstra with BFS, or what is this? like there are a lot of score, right, as a minimum edge cost along the path. Okay, total recovery cost of all edges does not on the path does not exceed k. Total recovery cost. Okay, what does total recovery cost mean? Do I need to like sum up the costs or what? And for each valid path, define its score as the minimum edge cost along the path. So I need to return the maximum path score, that is the largest edge cost, minimum edge cost. Yeah, that is the largest minimum edge cost. Yeah, okay. Among all valid paths, if no valid path exists, then return -1. Okay, that's all right. So first I can just simply do try to do a DFS and try to see if there is some path whose total recovery, like the total recovery cost of all the edges on the path does not exceed k. If I have something like that, then I can, if I have, yeah, so I think this is possible to do. Okay, so the only thing that I am having a doubt right now is what does they mean by total recovery cost. So doubts can be cleared by doing the examples. So let me try to do the examples. A graph have two positive roots from 0 to 3. Has it? So this is the graph and everything is online. Yeah, and the k is 10. All right, the k is 10. Okay, so I need to travel from 0 to 3. So what I need to find the maximum path score. Yeah, graph has two possible routes from 0 to 3, which I can see from here to here and here to here, and which path is valid, like path from 0 to 1 to 3, total cost. Yeah, we are adding the things. It's not, path is invalid, this we're talking, if this is there then this path is valid, so the minimum edge cost along it, this is 3, which is okay. Yeah, all right, I think this is possible to do. Yeah, first what I'm thinking is I can just do a Dijkstra algorithm. Or maybe minimum Kruskal's algorithm. If I do a Kruskal's algorithm, it will give me the minimum spanning tree. It's already sort of like a tree, but I mean it's not an underrated graph, so I think I should do a Dijkstra and only travel those nodes which will result in a, so like if with a Dijkstra I can reach from 0 to n-1, I can reach the end using cost less than equals to k, then I can definitely say that it's reachable. So answer is not. But if I cannot, even with a Dijkstra, if I cannot reach here, then I'll just say that okay, it's not possible to reach, return -1 immediately. If it's possible to reach there, then I'll try to think something. Yeah, this is my idea currently. Okay, so in the Dijkstra, I am thinking of doing this particular thing. So I'm trying to do a Dijkstra and try to store some things. Like I'll try to store the cost. Okay, so this should be as minimum as possible, and I'll try to store the minimum edge width. Correct. This will be a tuple, and then I'll try to store the last. This will be the cost, and the last node that I was in, and from that last node, what was the minimum edge width, what was the thing, and and then this is just simple Dijkstra modified, a little bit modified Dijkstra, I think. Yeah. So let's try to implement the Dijkstra's algorithm here. So first of all, in order to implement the Dijkstra, we really need a graph. Yeah. In the graph, I am obviously going to store two things, which is two things, which is the node itself and the node's weight, which I can get from this edge. And if the node is online or offline, I can just use this one. I don't need to insert it here again, right? Yeah. And let's try to form the connections. So vector int p edges and u equals to p of 0, v is equals to p of 1, and g of u dot m plus back p, right? This is going to give me actually m plus back v comma w, and w is p of 2. Yeah, this is great. And this should be my this is what I will do, and I need to try to find the minimum, not minimum actually. It's almost like a Dijkstra, but it's not really a Dijkstra. I'll try to have the minimum cost, but still it is not like that I won't explore other possibilities as well. I'm just not going to explore those possibilities in which costs are becoming greater than k. I'm not going to explore those possibilities. Except for that, I'll just consider all of the possibility that I can get, right? So let me carefully do this. First, I'll have I don't know if I'll have a visited. Like I can visit the same thing again and again and again, but it's there is no cycle. There is another thing. There is no cycle. So it's one of the very, like I can just do a simple Dijkstra and not worry about cycles, because there is none, which is quite a good thing. Okay, so let's try to make the priority queue at first. Priority queue. The priority queue, I am obviously going to store the cost, the minimum edge weight, and the node. So initially I am not visiting any edge, and the maximum edge that I can actually get, you can see here, cost I is at max 10 to the power 9. So maximum edge weight that I can get is 10 to the power 9. So it fits inside a integer. And if I talk about this guy over here, like edges ui and vi, it also fits. So these two guys can fit in an integer, and let's talk about what cost will be. So Minimum edge weight, right? What is the edge weight, by the way? Edge weight. I think it's not talking about the edge weight, but recovery cost. Nodes may be offline. Okay, minimum edge cost along the path. Yeah. So there are total of so it can go to 13. So I need a long here. So let me use a tuple long, and then this is minimum int. This is also int, and this is obviously should be in a vector tuple long int, and then greater tuple long, yeah. This will be the priority queue. Okay, now I am do you think I need a visited array? Like if I have already visited someone with the node, should I not visit it again? I think I should visit it again as well. So I don't need a visited array, but I clearly need a distance array. So yeah, let's have a distance array test, which will be everything will be int max in the beginning. So not int max, it will be long max. Okay, all right. Now what the thing that I need to do is, distance to reach 0 is always going to be 0, and another thing is that the what I'll insert into the priority queue. So in the priority queue I need to insert cost. So the cost initially is literally just 0, right? Yeah, there is no cost. And then if I talk about the minimum edge, initially there is nothing, so I'll go with the long max, or maybe I don't know. And the node is u, right? All right, so this is quite a good thing. And I actually don't know what the tuple actually, like how can I represent the tuple, but I think it can be represented like a vector, something like that. Maybe I can use a auto to do decode a tuple. So yeah, I did this, and now I am just going to do this while pq is not empty. Try to do this. So int u will be pq dot front, sorry top, and pq dot pop. Yeah. Okay. So okay, it's not int u, it will be auto. The cost, which is let's say the cost, and the minimum, and then we have the node, right? This is what it will be. So cost, minimum, and u. And now I'll be okay. So I'll try to explore the all other possibilities. So there is no cycle. There is no way I can reach something. So for int v, then g of u, and actually it's a pair, so I am going to do this v comma w. Yeah. So the thing is, I am only going to visit v if it's online. Okay, if it's online, and add v plus w, sorry, not v plus w actually, the cost plus W is less than equals to K. If this is the thing, then only I am interested, right? If this is not the thing, I am not interested to travel, to go there, and there is not going to be a. So I am literally exploring just all of the paths, and there is not going to be a cycle, so I don't care about getting a TLE. I think I am thinking, because if there is no cycle, here I can come this guy, I can do this, I can also go this, like like a tournament. So like there are not going to be a lot of I don't think there's going to be, like, if the distance is lesser, I am interested, but still I'm not really interested in the distance, to be honest. This distance that is here, I am literally not interested in that, but right, so I can just tell bye bye to the distance, and I'm like, okay, now let's talk about this. So if this is the case, then I'm like, okay, push it to the priority queue. What I'm going to push, so the first thing that I'll push is the cost and min of minimum comma W, and then the node itself, right? Yeah. So whenever I reach the node n-1, I'm just going to do this. Let's talk about the maximum, which will be, let's say, what is the max? What is the cost? Cost cannot be negative, so let's say this is -1 initially. If I can see that like there is, you can reach -1 with a cost less than K, and there is some minimum out here, right? Then I'll be like, okay, maximum is equals to max of maximum comma minimum, right? So whatever here is, I'm just going to take the maximum, right? And then in the end I just return the maximum. I think this should work, I don't know, but I'm worried about if it will give me a TLE or not. So the first one is it shouldn't be -1, right? So there is definitely some problem with the approach. Okay. If u is equals to n-1, then maximum is equals to maximum comma minimum. What is wrong, guys? I'm just getting -1 only. Or also I don't think I also need a priority queue, to be honest. Do I really need a priority queue? I don't think I need a priority queue. But the problem, what is the problem that I am like, that I'm facing? So okay, so let me try to do a dry run here. I don't know what's wrong with this. Okay, so let me try to do a dry run. Okay, so first of all, maximum is minus 1. In the priority queue, I'm having 0 cost initially down in the node 0 over here, and then I'm going to do this. So this node is out, is 0 and minus 3 is 0 3. He'll be like no, so he'll come here and I have these two things. So first let's say I'm visiting this node. Is online? Yes, online is, and cost plus w is less than or equals to k. Cost of this cost was 0, and here cost plus w, which is 5, is actually less than 10. Then yeah, so I'll push this guy over. So I'm like, okay, pq.push cost plus w, cost 0 plus w, which is 5, and minimum is long max, and oh, I think this is the, should be int max, right? I think that's why it is not working. And also one more thing I have to make sure is that, like, I don't want to do, like, if the weight, if the minimum here is like the w, so like the minimum that I have and the maximum that I'm getting, or let's talk about this, min of minimum comma w is actually greater than or equal to maximum, then only I'll push this, right? Or else I'll just not push it, because I already have a maximum which is greater. I don't want to, like, obviously go to that part which is going to hamper what I already have. So I'm just going to not do anything, right? So this, I think this will work, but queue I can do it go with queues, but yeah. A TLE is definitely a TLE. Okay. So yeah, priority queue, I think it's too much. Maybe I can just use queues, normal queues instead. So instead of priority queue, let me use a queue. Let's try to see if this works or not. And it should be front, right? Yeah. Okay, so I'm getting a memory limit exceed. Damn, I was so almost close. I was like, how many edges can there be at max? Edges will be always minimum of 10. There are not many edges. How can it? So memory limit will be only here then. That's what I can see, right? What extra can we do? I think I can do this thing, make a vector of dist, which will be initially int max, right? Why am I trying to do this is, I'll tell you the reason. So so as soon as I can see the distance, it doesn't solve the problem. There has to be something I'm visiting extra, or I'm not visiting something like that, right? Fine. These cases are all right. These cases are going to prune a lot of things, but still I'm not able to think about some other possibilities as well that can happen. Oh yeah. I think this thing, whatever the minimum is, it should be even not equal to maximum, but should be greater than maximum, right? This is one thing that it should be. And another thing is, I don't really know what to do now. This thing is going to prune a lot of things, but still I don't think it. What, did it work? You gotta be kidding me. Okay, memory limit exceed 530. So there are again a lot of things that I'm just reusing. So I need to come up with lesser things. Okay, let's try to do this. Vector int min edge and comma -1, or should I again use just a priority queue again? I think it will not give me a TLE. What do you think? I'm just, in this queue, I'm just trying to do a brute force. It's almost a brute force. I just need to not make it brute force. That's it. How am I going to do it? That is what I need to think about. What extra am I doing here that I should not be doing? Yeah, I think I should prune them beforehand. This is what I can do, min edge. Let me say that this is min edges. So if I see that the min edge of V and the minimum here is greater than the min edge of V, then only I do this. And when I do this, it will be something like I'm going to change min edge of V to min of minimum comma W, and this is just going to be min edge of So if this guy is greater than this guy over here, then I add this, and I should delete that particular thing, right? I should not work with that particular guy. And min edge of 0 is let's say it's int max. Why? Because as you can see here, it's int max. That's fine. And everything is, let's say, -1. If I can see that I have some minimum edges which are greater than the minimum edges that I initially had. Then only I do this, else I'm just no, I cannot do this. I cannot do this because of certain reasons. I just simply cannot do this because because there might be like cost can be very high, like that, like there might be some mean age in which this guy is smaller, even though it's smaller, but the cost is also very small. It might be possible that for this guy, for if it's greater than min v, it cannot even reach this u equals to n minus 1. But if minimum, if this is lesser, even though if it is lesser, then it can be possible that it reaches that guy at least. So yeah, I cannot actually do this. So yeah. So what else is left? Like I can not even do visited, right? So let's move this. This is again the maximum. So instead of this, I think I have to use a visited array or something like that, correct? Or else this is just not going to make it look good. But if I use visited, I will not be able to revisit the thing again and again. Let me think. Okay, what can we do? If I make a visited array, I can actually do something. Oh wait, I can do a binary search instead, right? Yeah. I can do a binary search. I can do fucking binary search. That will be n log n square. I can do a binary search. Okay. Let's try to do a binary search, and the binary search will be again priority queue. I'm going to use priority. Oh, I need to write the lines again. Vector tuple long int this, yeah, and again one more, and then greater tuple long int 1 2 3 4 5 6. Yeah, what I'll do now is do a binary search. P is 0, Q is how long can it be? Oh no. How long can it be? 10 to the power, cost can be 10 to the power 9, so 29. And R, okay. Yeah, and also like here I can also use this visited. Oh yeah, I can just do this. Less than q is equals to max of q comma w. Let this be is alright, I think. Yeah, this should be okay. This is also okay. And now visited. Now we are going to use the visited array. Okay. I think binary search will work for some reason. While p is less than equals to q, this will be the thing. And now I will do this. Visited of z is already equals to 1. Now here I am only going to do this if I have not already visited the v. And try to find the shortest path as possible. Okay. So it will be something like how can I find the shortest path? Here also I will do this thing, visited of u equals to 1, and if this is not visited, only then I will check these guys over here. And where is the maximum that I was having? Okay, let this be maximum. So maximum is just equals to p plus q by 2. Okay, now we are talking. So I am going to do these things, but instead of this I will be like, okay, I'll just do the shortest path algorithm instead, like do a Dijkstra instead, correct? Like instead of this I'll just do a Dijkstra. So I'll just have the distance which will tell me the cost, and I'm not going to do this. Okay, so Dijkstra, how do I apply Dijkstra? So let's forget about these things over here for a little while. I'm just going to do Dijkstra. So Dijkstra, I can only do if these are the things. So cost plus I is less than k. Dist, it's initially int max, long max, right? Here I have to do this thing, dist of 0 equals to 0, visited of 0 is not initially 0, and this is the thing that I'll do. Okay, I pushed into pq dist 0, and this is also 1. Okay, now if this is and dist of v is less than u plus w, then I am going to do this thing, pq dot push this, and in the end I am just going to find the dist of, let's say, the maximum. And one more thing, I'm just only going to take those whose weights are greater than or equals to maximum. If w is greater than or equal to maximum, then only I'm going to do this. Okay. And what's minimum over here? Minimum is the edge weight initially. So this is going to be this. or maybe I can just say minimum of w comma. Minimum of w comma minimum. Yeah. Okay, so I'm only going to take those whose weights are. Okay, so one more thing I just realized is that I also don't need the tuple. I only need the cost and u, right? So I can just, write a pair instead. So let me just erase everything, like a whole new idea. I should have thought about it earlier, that this can be a binary search question. I wasted a lot of time in this question. Okay, so this is just this thing, and these things are correct, and yeah, I don't need this. Yeah, and just this will be w. Yeah, I think this is very correct. So if I can reach the distance, if dist of u, sorry, n minus 1 is actually lesser than equals to k, and that if I can reach it, then this thing is possible. So I'll be like, okay, p is equals to maximum plus 1, so I can try greater maximums as well. Okay. And if this is not true, then I need to try lesser weights, so q equals to maximum minus 1, right? So this is what I am going to do, and the answer to this thing is going to give me by which one? So this is going to, q is going to give me the answer, right? Because q is the one which is always going to, so q. Yeah. I hope this works. What is this? Okay. This will be top. Is there any other? Vector int long lines, okay. Anything else? No? Okay. What? Minus 1? Oh man, not again. Oh, this is mistake. Cost. What's wrong? Is my Dijkstra wrong, guys? Like if it's not visited and it's online, then I do this. If cost plus W is less than k, less than or equals to k, the distance is also less than cost plus W. What is wrong, guys? What is wrong here? I don't see anything. What mistake am I doing? Somebody tell me. I'm literally doing the extras algorithm, trying to find the shortest path. Okay, let's you know what? Let's try to remove this and try to see if the shortest path will give me lesser value than this or not. Just this. Okay. Still not working. Where the minus? Why is there a -1, guys? Tell this is. How am I getting a -1? The maximum edge weight that I can get. Is this. I don't think today I'll also be able to complete the fourth question. Complete what? I won't be able to able to read the question. If cost is there and the node is there, then do a simple Dijkstra. This is a simple Dijkstra. Why simple Dijkstra is not working? Somebody tell me that at first. If I have not already visited V, and if V is online, right, then I check if the distance cost plus W, cost plus the W weight, is it going to be less than the distance V? Oh, plus W. Again a fucking time limit exceed. This time I am getting a time limit exceed on other. Like binary search and Dijkstra is also not working, guys. That's if first I find u equals to b, I just break. And also I want to do this thing, is that cost plus w is less than equals to k initially, then Dijkstra plus binary search not working, guys. How is it even possible? Somebody tell me. This should not. This is not possible, guys. Dijkstra, it takes e log v, which is almost like e log e. And if you can look at this e log e, then it's almost like n log n, right? This log this, and there is additional log factor of edge weight, log of this guy, like 9 log 10. So it shouldn't be so bad. Oh man. Literally binary search plus Dijkstra is not working. What is my rank here? It's gonna be very bad. I am pretty sure. Yeah, I just told. What did I say? It's gonna be very bad. Should I just set instead of a priority queue or what? Like set is better or like priority queue is better? Just 5 more cases. Time would exceed its giving. Ten to the power 5 log 5. 10 to the power 5 log 5 square is log 5 into log 9, which will be 5 log 10, 5 into 9, which is 45, into 2, which is 90, 90 log 10, 90 log 10, 100, and if I submit 100, it should have been like, should I do DP now or what? Like, what the fuck? Why is the extra not working? Or should I not use the extra? Should I not use the shortest path? Or what? Should I just use a DFS? DFS won't work. Like, how can I do it? Okay, guys, I don't think I will be able to do this. I didn't even read this question number 4. Oh man, it was a digit DP question. Shit. I should have done this question number 4. Okay, now I think I should at least do it now. You're given 2 integers n and k. It looks like a digit DP, or it can be also a maths question. For any positive integer x, define the following. P of 0 is equals to x. P of I plus 1 equals to pop count of P of I. Okay. Okay. So it's always going to be smaller and smaller and smaller, something like that. It's a decreasing array. This is what this is about. It's going to be a decreasing, okay, for all I, okay, pop count of y is the number of set bits once I know that. Sequence will eventually reach the value 1. Yeah, okay, that I know for sure, right? Unless x is 0, then it will reach 0. If x is greater than 0, then I don't think it will reach. So for example, x 7, then sequence this 7, 3 and 3 will have 2, yeah. So the pop count of this 3. Okay, the task is to determine the number of integers in the range 1 to n whose pop count is exactly equals to k. Okay, my task is to determine the number of integers in the range 1 to n whose pop count is exactly equals to k. Okay. Oh. What if I try to think what if I try to think in the reverse? Like if I am having 1, then from 1, how many are there which has 1? Either 2 or 1, correct? So here depth is 2, and here also depth is 2. So I'm like, okay, let's try to go towards how many of whose pop count is 2. So there are a lot of numbers whose pop count is 2, correct? Like there are almost okay, there are a lot of numbers who has pop count 2. In fact, there were a lot of numbers who has pop count even 1. There is like 2 to the power k. 2 to the power k? No. I think long time. Okay. There are a lot of numbers who have a pop count of 1. But it cannot be, this guy cannot be more than 13 unless k is 2. If k is more than 2, then this guy will act like it has to be less than 32. So 30, if it is less than 32, then like from 1 to 32, how many of them are there? Like in depth, if we're talking about depth 2, this many, there will be many numbers who has only 1. So let's talk about this. If you have a 64-bit number, when I try to do, okay, count the set bit of 64, just one, about 63. Okay, anyways, that's it. I don't think I will be able to do it. So that's it for today's video. Only 2 questions solved again. Yeah. Bye bye.